We're getting a pretty good crowd here. We've got about 32 people. We'll got another minute or so. Okay. Okay, I think we'll get started. Are you ready, Dr. Petty, to
Yep.
Okay. So I will start with the introduction. This is Dr. Petty. She is at the University of Otago in the Department of Nutrition, and this Otago is in Dunedin in New Zealand. So welcome to us. She's a day ahead of us. She's on to Friday right now. She received her BPhED at the University of Otago, and she received all her degrees there, her master's and her PhD. And then upon completing her PhD in 2012 and then until 2020, Dr. Petty worked in the department in various research positions. These positions were, and she is and has been funded by the Heart Foundation of New Zealand, Lotteries Health Research, and the New Zealand Health Research Council. She just joined the Department of Nutrition as a senior lecturer in February of 2020, and her main area of research focuses on how interrupting sedentary behavior with short bouts or regularly performed activity can impact postprandial metabolism, energy balance, endothelial function, and most recently, she's looking at sleep. In her teaching, she teaches about the links between nutrition and non-communicable diseases. Um, she has, as I said, well funded. She's got a number of publications as a junior researcher, and it's our pleasure to have her here today and let her present on the work that she's been doing. So, Dr. Petty, if you want to go ahead.
Oh, thank you very much, Jill, and thank you so much for having me. It is a bit funny thinking that you guys are kind of coming to the end of your afternoon and I'm about to start my day, but we'll go with it. So, this is just a picture of, I was telling Darius before, this is a picture of our campus, but it is the pretty side of campus. My building sits across the river from this one and it is just a concrete box, and we're just coming into spring here, so we're just starting to get some of those green leaves on those trees. And just for those of you that might not know, this is where we are down, all the way down here in New Zealand. Dunedin sits is kind of one of the southernmost cities in New Zealand. It's in the University of Otago. Does it all the way down there. That picture probably does make it look a bit further away from you guys than it really is. This map, if we go the other way, you can see that this is here. So it's actually Māori Language Week in New Zealand. Māori are our Indigenous people of our country. And so one of the things that is really important in Māori culture is introductions, and particularly to talk about where you whakapapa from or where your ancestors come from. So I use this slide with my students, but I thought it was maybe appropriate here because I do show some links to the States here. So my dad actually grew up in Massachusetts. His father is of Cape Verdean descent, and his mother is half German, half Portuguese, which explains all this kind of ancestor where my ancestors come from in that regard. My mum was born in New Zealand, and most New Zealanders of European descent kind of whakapapa or have their ancestors in Scotland and England. And that is where she comes from. She actually went to the States on AFS exchange when she was in high school, met my father, came back, completed university here, and then went back and got married. So I was born in Massachusetts, but we moved to New Zealand when I was 3, and I've been here ever since. And this mostly covers what Jill has highlighted there. So I did study both physical education and nutrition at an undergraduate level. I took a break and went and worked before my undergraduate training, but then completed my PhD in 2012. And 2020 was a great year to start teaching, I have to say. At least I wasn't used to anything else, so I guess I've been able to roll with the punches with going in and out of lockdowns and all that fun stuff. So yeah, and I do spend most of my time researching about central behaviour, which is what I'm going to talk mostly about today. But Catherine, when she contacted me, did ask me to talk to you a little bit about our direct study that we have been running. I've been involved in running with some colleagues, so I will touch on that at the end there. So just yeah, sedentary behaviour. So what I thought I would do here is just kind of take the approach of trying to answer some questions that I regularly get asked about sedentary behaviour. So I'm just going to cover off some definitions and how sedentary behaviour is associated with health initially, and then try and answer some of these common questions, which relate also to my research in terms of particularly the pattern of accumulation, but some other ones. And then we'll talk about Te Kaika Direct. So just so we're all on the same page, sedentary behaviour is defined as any waking behaviour characterised by an energy expenditure of less than or equal to 1.5 METs and a sitting or that is performed in a sitting and reclining posture. Sedentary time. I know we used to be really good at calling people that were not physically active sedentary, but we're trying to move away from that now as this field of sedentary behaviour has developed. So if people aren't meeting the physical activity guidelines, we try to refer to them as inactive. And if they are sedentary or sitting for long periods, or sitting for long periods, then they would be sedentary. So just thinking about those two words in slightly different ways. And I guess one of the things that we need to think about when we're thinking about sedentary behaviour is it just takes up such a big part of our day. So if this kind of slide is meant to represent possibly a usual day in which people spend and how much time they might spend sitting in different activities. So obviously they're asleep or they're asleep possibly between 11 and 7, but you sit down to eat. You possibly sit down to commute, depending on how you commute. Most of us sit at work, although you might notice that I'm at a standing desk. And then we sit down for lunch, we sit for another 4 hours in the afternoon, you commute home, you have dinner, and then we spend quite a lot of our leisure time in the evening sitting down. I will talk a little bit more about that a bit later. So you could potentially be physically active, right? You could get your 30 minutes of physical activity in a day and still spend about or more than 14 hours being sedentary. So what is this possibly doing to our health? So this is a meta-analysis of 34 studies involving 1.3 million participants. And we have relative risk of mortality for different diseases on our y-axis here. And on our x-axis, we have total sedentary behaviour going from 0 hours to 16 hours. Our dashed line represents the associations when you don't control for physical activity, and the solid line represents the associations between sedentary behaviour and risk of mortality when adjusted for physical activity. And what you can see is particularly when we get above 8 hours for sedentary time, you can see that that risk starts ramping up in terms of both all-cause mortality here and CVD mortality. For TV viewing, those associations are stronger. So they start at 4 hours, and you can see that those lines tend to be a little bit steeper. Kind of less certainty there around cancer mortality and incidence of type 2 diabetes, but you can see there again that for TV viewing, those associations are much stronger. There's lots of speculation about why TV viewing is worse than total sedentary time in terms of possibly other behaviours that go along with TV viewing, such as snacking and maybe that more prolonged sitting that we'll get to in a minute. So those were, of course, that meta-analysis is looking at cohort data or observational data. In terms of randomised control trials, we are starting to see some randomised control trials emerge or results in the last 10 years or so. Most of the randomised control trials trying to impact sedentary behaviour have focused on reducing occupational sedentary time, which makes sense in some regard because that's probably the biggest chunk of the day that we spend sedentary. Most have generated kind of reductions in sitting time of around 45 minutes over an 8-hour workday, and they have induced modest improvements in markers of cardiometabolic health. So this is just an example of one of Genevieve Healy's studies, where you can see that when you look at overall cardiometabolic risk score, we see a reduction, an improvement in the overall risk score at 12 months, which is really just the result of very modest changes in the right direction of kind of the more traditional risk factors there. Right, so hopefully there you've got some understanding then that sedentary behaviour is probably associated to health in some way. But one of the questions I get asked, particularly by my sports science colleagues, is, but I'd have to worry about how much to sit, how much I sit because I'm very physically active, right? And so this was some work that was done several years ago now, again, looking using meta-analysis of data from 16 studies and about 1 million people, where they were able to kind of uniquely group people both by their sedentary time and the amount of physical activity they are doing. So hazard ratio for total mortality on our y-axis, and on our x-axis we have quartiles of physical activity, where these people are the lowest quarter of physical activity, and these people are the quarter of the group that do the highest amount of physical activity. And then within that, they've categorized people into sedentary behavior. So you can see down here, the least active people in terms of physical activity, you can see that really strong association there across categories of sedentary behavior, indicating that the more sedentary behavior you accumulate, the higher your risk of all-cause mortality. You can see that that relationship still exists in both of these categories here, but doesn't exist at the highest level there. So these people that are doing the most physical activity are probably actually protected in terms of their risk of sedentary behaviour, if you look at this analysis. But at least in New Zealand, most people, we struggle to get people to meet the 30 minutes of physical activity recommended. So this in this quarter is kind of probably where most of our population is, or at least in these two quartiles down here, and you can see in that group still very strong associations with sedentary behaviour and increasing risk there. So for most people, we probably do need to worry about a sedentary time, but if you are very physically active, maybe not so much. Another question I get asked all the time is standing enough to protect you from the perils of sitting? So acknowledging that there is a lot of evidence out there suggests that indicates that standing for long periods is not great for things like back pain and lower leg pain. Although some people who have back pain prefer to stand. I guess it depends on what's wrong with your back. People report fatigue, discomfort, and then there are some questions about venous insufficiency in terms of standing for really long periods. However, when you look at the literature, at least observationally, it does look like people who are standing almost all of the time have a lower risk compared to people that are standing almost none of the time. And that applies actually both for people who are active and people who are inactive there. We did do some work where we got people into the lab and asked them to it was a crossover study, so we asked them to sit for 360 minutes on one occasion, stand for the entire time on another occasion, and do some regular activity breaks on the other occasion. And what we did find is that prolonged standing does actually improve blood flow. So here we can see blood flow in the sitting condition, and in both prolonged standing and regular activity breaks, we see improvements in blood flow at 60 minutes. That was maintained at 240 minutes, but actually the difference was no longer there for prolonged standing at 360 minutes, but was there for our regular activity breaks, which is getting up regularly and walking around. So some indication there that prolonged sitting is probably better than prolonged standing if you can manage it, but moving is probably the better option there. And this is probably the area that I spend most of my time thinking about is does the pattern of accumulation matter? So this picture comes from some work from, again, Genevieve Healy and David Stunson's group over in Melbourne, where they looked at participants in the AusDiab study, which is a study looking at risk factors for diabetes in their population. They had accelerometers on these people, and they looked at the pattern of accumulation. So believe it or not, these two individuals actually have the same amount of total sitting time, which is in yellow, and the same amount of sedentary time, which is in green. Oh, sorry, active time, which is in green, right? So we've got the same total amount in these but you can see this individual accumulates sitting in much longer bouts than this person who is up and down all of the time. And what they found with this kind of observational study was that the people that interrupted their sedentary time regularly had lower weight, better fasting glucose and insulin sensitivity, and lower triglycerides than the kind of people that were prolonging their sedentary accumulation. Around the same time, these papers, a series of papers, came out looking at the effects of sedentary behaviour in rats. So these studies involve putting rats in cages and either allowing them to ambulate around their cage normally, and apparently rats do like to walk around quite a lot when they're in their cages, or they immobilize them by tying their tails up to the top of their cage there. And you can see that when they were standing or being ambulatory around their cage, our LPL activity, so lipoprotein lipase activity, was higher than it was when they were inactive. When they then compared that to running on a flywheel, that didn't increase their LPL activity any further than it did with the standing. And so this kind of led to a lot of people thinking that maybe the biological mechanism for the associations we were seeing with sedentary behaviour was maybe due to this upregulation of lipoprotein lipase activity, which then did lead to a series of studies that were performed around the world, including my PhD research, where we looked at performing the effects of regular activity breaks on postprandial metabolism in a laboratory setting. So this is a picture of some of my participants, one of my participants here. So they spent a lot of time in our little blue comfy chairs, and then on in the condition where they were up and walking every 20 minutes, they got up half an hour, sorry, they got up and walked on the treadmill for just under 2 minutes. We had them in the lab we had them in the lab for 9 hours, but across the different studies now, those that kind of ranges between 6 and 9, and those activity breaks have kind of settled most of the time now on about 2 minutes every half an hour. There are some exceptions to that rule. We had accelerometers and heart rate monitors on our participants, and so this is to give you an idea of what the 540 minutes looked like from that perspective. So counts per minute here, you can see that in the prolonged sitting time, they were quite sedentary, and their heart rate was reasonably consistent there. We do, of course, recognise that sometimes emotional responses trigger heart rate, blips in heart rate. This particular participant got a nice text message from his girlfriend at that point, which increased his heart rate. And then we have the regular activity breaks condition there, and you can see, of course, that they're up and moving every half an hour, and we get a nice spike in heart rate corresponding to that little walk on the treadmill there. But what happened to the glucose? So this is our glucose concentrations here on the y-axis. Time is on the x-axis. Our activity breaks are indicated by the little blue up arrows there. The purple arrows indicate when we fed the participants, and that red block is actually, we did have a third condition in the study where they walked continuously for 30 minutes. So our red line along here is actually when we when they walked for 30 minutes continuously at the start of the day and then sat continuously. The green line is sitting continuously throughout the intervention, and the blue line is our regular activity breaks. So you can see there quite a nice reduction in our glucose concentrations across the day when we walked continuously. We don't get too excited. I don't tend to talk about the physical activity being kind of almost higher than prolonged sitting here. They did walk in a fasted state here, so I think this kind of falsely elevated their glucose there, which was pre-meal, which has led to that the incremental area under the curve being higher than we expected. And so it's not just me that has found this study. There's now been a series of studies that have looked at the effects of activity breaks on postprandial glucose responses. And we can see across both the moderate and particularly moderate intensity and light intensity activity breaks that we see modest reductions or moderate reductions in postprandial glucose responses. Standing, we do see a slightly less consistent result, and there is some thought that maybe that has to do with the kind of metabolic health of the participants there. Similarly, we see reductions in insulin there. So not as many studies measure insulin. It costs a little bit more, particularly when you're doing those serial measurements across the day. So not everybody has measured insulin, but when we do measure it, we do tend to see consistent reductions in insulin. And in fact, sometimes the studies show reductions in insulin when they don't observe reductions in glucose, which is still important, right? Because it means that we're clearing a similar amount of glucose with less insulin. So probably that those activity breaks are upregulating those non-insulin mediated pathways in terms of glucose regulation. But what we didn't see, and what we quite a few studies haven't seen, is a reduction in triglycerides. So if lipoprotein lipase in the rats was the thing that was explaining, was the biological mechanism that was explaining our associations between sedentary time and health, we would have expected to see reductions in triglyceride, but we didn't. And you can see from this meta-analysis data that several studies haven't done that, which led us to kind of ponder this. So obviously the first suggestion, of course, is that humans aren't rats. Lipoprotein lipase might not be the primary biological mechanism. But when you go back and look at the literature which looks at the effects of physical activity on lipoprotein lipase, there does seem to be a lag there in terms of when lipoprotein lipase kind of upregulates in response to exercise in humans. So this led us to do another study because we were like, oh, maybe we need 16 hours. Maybe we just need 16 hours of activity breaks, which no one had done yet. So we did a study where we got people in for 2 days continuously, or 2 days back to back. They did go home to sleep, and looked at triglyceride responses along with glucose and insulin. And indeed, on that second day, we did observe reductions in triglyceride concentrations there with those activity breaks, regardless of whether they did combine them with physical activity or whether they just did them alone there. So it could be particularly in healthy people. Sorry, I should have said that to begin with. I tend to do my research in healthy populations. So there have been some studies that maybe show reductions in triglycerides on day one, but they tend to be in probably less metabolically healthy people there. But we can induce reductions in triglyceride response with activity breaks if we have the right timing. So one of the things that we were kind of doing at the same time that we were doing those lab studies is starting to look at what people were actually doing out there in the real world in terms of physical activity, or in terms of, sedentary time accumulation. Excuse me. And one of the things that we identified there is that most people do spend the biggest chunk of their day sitting at work, but possibly they don't accumulate that time in as an interrupted manner as we uninterrupted manner as we thought. So what is the time that of the day that people sit for the longest period uninterrupted? And it actually appeared that that was happening outside of work. So in our non-work hours was when we were accumulating our longest uh, periods of uninterrupted sitting. And I say our here because the study was actually done in university employees. It says office-based, but yes, yeah, university employees there. So outside of work, and we knew from when people were wearing the accelerometers that based on when they put the accelerometers on and when they were starting work, that this long period of long sitting must have been happening in the evening. Some other research internationally has also indicated similar things. So some work by John Ballantyre and his colleagues in retired people, which is an interesting one because they wouldn't be necessarily following the same patterns as people who were working. But you can see here that the number of bouts, either 20 minutes or longer, 30 minutes or longer, or 60 minutes or longer, does tend to ramp up across the day. So people are accumulating longer periods of uninterrupted sitting more towards the evening, with the woman in this graph in the pinky red colour and men in the green there. And also some work in Australia, again, also indicated a similar thing. So in people with type 2 diabetes, sedentary time in the evening was greater than it was in the morning, and the number of interruptions in the evening was less than the number of interruptions in the morning. So it really seems like people are accumulating their longest bout of sitting in the evening. For most of us, the evening time is also a time of higher energy consumption. So some statistics would indicate that some people consume up to 40% of their total energy in the evening. We do also see diurnal variation in insulin sensitivity, where insulin sensitivity seems to be at its lowest in the evening. And as I've already said, prolonged sitting seems to be a thing in the evening. So that led us to one of our more recent studies, looking at whether we can get people, what happened if we got people in the lab in the evening and got them up and moving regularly. So we recruited healthy adults between the ages of 18 and 40. They needed to self-report spending more than 5 hours a day sitting. And we did actually recruit 10 healthy weight participants, 10 overweight participants, and 10 people who are living with obesity, because there has been some suggestion in the literature that maybe the effects were greater or in people who were heavier, but that was comparing different study populations, so no one had done that comparison. Unfortunately, we couldn't power a study to look at the interaction because we would have needed to have 4 times as many people, which would mean that we're probably still down there collecting data now. But the idea here was that we could do some kind of exploratory look there at what was happening across the weight categories. So this is what our evening looked like in terms of the participants coming into the lab. So they arrived at 5:30 and they had a cannula inserted into their arm for blood draws. We also put a continuous glucose monitor on them, but that was really to look at what was happening after they left the lab. And they either sat continuously or on one occasion, and on the other occasion, they got up and did regular activity breaks every half an hour. In this study, we actually chose to use resistance exercise or body weight resistance exercise rather than getting people to walk on the treadmill, because a lot of people had talked to us about, well, when we started talking about the study, people was like, I'm not going for a walk in the evening. I'd have to turn off my streaming that I was doing to and people didn't want to interrupt that. So we tried to design or we tried to use a series of exercises that would you could do still watching whatever you were watching on your device. So we did my master's student Dorothy, who features in this video. We took her over to our media production unit here at the university, and we made a little exercise video. And this is what the participants did their exercises in time to every 30 minutes when they were in the lab. So squats, knee raises with a hip extension, and some calf raises. Does somebody have a note? Okay. And what did we find? So again, we've got glucose concentration here on our y-axis and time. Here along the x-axis, our prolonged sitting is in orange and our regular activity breaks are in blue there. And if we calculate the area under these curves, the glucose or incremental area under the curve there, the glucose in the regular activity breaks was 32% lower than it was in the prolonged sitting condition. And similarly, with our insulin, we see a 27% reduction in insulin across that time period compared to prolonged sitting. I didn't stick in the different, if we separate them across the categories there were reductions in every category of weight in terms of groups. Interestingly, when you looked at the insulin concentrations, the total area under the curve for our people with obesity was much greater, but we still saw reductions, similar reductions across the three groups in terms of the effects of regular activity breaks. So one of the things when we were designing the study was that we kept on getting questions about what would that do to sleep, right? In the sleep recommendations, there are some words there around trying to avoid physical activity before you go to sleep. I acknowledge that they are probably talking about more intense, sustained physical activity than what we are doing. But people were asking questions, so we figured it was worth putting some accelerometers on people and measuring sleep after they left the lab to see if it had an impact. Really anticipating that we just wouldn't see a difference there with the sleep. So the participants left the lab wearing an accelerometer. They actually did wear it for a full 48 hours after they left the lab. And then we processed that data and what happened? They actually slept for longer. So when they were doing the regular activity breaks here, we have a almost 30% extension of both sleep duration and total sleep time. And when we looked at the self-reported times that they were waking up, it appeared that that sleep extension happened not because they were going to bed earlier, because they were tired, because we'd made them exercise throughout the day, but because they slept longer the next day, which was quite an interesting finding. And we've had some fun doing some media, talking to the media about that kind of recently, and when that study was published. As I've kind of alluded to, this was mostly the work of Jen Gale here, so my wonderful PhD student who is about to submit her PhD at the end of the month, less than 10 days to go, so she's frantically formatting things. But she's looking for a postdoc if anybody's interested. So, of course, one of the other questions that I get asked a lot is it the sitting more or moving less that is the problem? And this is probably the question that we don't really have the answer to, right? Because it's so hard to untangle those two things, right? Because if you sit less, you have to, by default, move more. So it gets quite hard to disentangle those. There have been some kind of gene expression studies where it looks like bed rest turns off. So if you're completely inactive, there are some different pathways that get kind of turned off compared to the genes and pathways that get turned on when you're active. So probably a combination, right, of the two there in terms of sitting more or moving less. So in terms of sedentary behaviour, we know that it's a risk factor for cardiometabolic disease. Physical activity in high levels might be protective, but the pattern of accumulation does matter. And you're probably better to try, or you should be trying to interrupt periods of prolonged sitting. But there's still lots of questions to be answered there. I always get questions about, well, what is the optimal activity break? What is the optimal timing of those activity breaks? And while there has been some work done there, there's still a lot to do there in terms of looking at all of that exciting stuff. Okay, so I am going to move on just in quite a different manner to talk about the direct study that we've been doing here in Dunedin. Although I have to say, Mike Lean in the UK is currently working to kind of make some rules around what constitutes a direct study. So I've called it direct, but we possibly shouldn't have done that, but that's okay. So just a reminder in terms of, if you haven't heard of the original direct study, there was a study done in the UK led by Mike Lean and Roy Taylor, where they did this diabetes remission for clinical trial for weight loss in the UK, which involved getting people with type 2 diabetes to follow a total diet replacement program for 12 weeks, followed by a stepped food reintroduction phase and then a weight loss maintenance phase. The participants on average in the study lost 10 kgs, and 46% of people in the total diet replacement arm of the study were in remission at 12 months. So quite striking findings, which has led now for in the UK. This program is now a funded program for people with type 2 diabetes and overweight and obesity. So anybody in the UK can go and see their family doctor and be referred into this program if they have type 2 diabetes and they're overweight. So we actually were approached by a health provider called Tukaika, which is a health provider in Dunedin that specifically caters to our Māori Pacific refugee and low-income clientele. And they really wanted some help to help support their patients with type 2 diabetes to help them manage their condition well. So we knew that direct was effective and acceptable in the UK, but we didn't know how it would be received in New Zealand, particularly when our Māori and Pacific people have really strong cultural connections to food and the importance of eating together. So asking people to go on a meal replacement program for 12 weeks might not have been an acceptable thing to do. So we decided to do just a little study where we looked at that. So we recruited a total of 40 people from the practice, and half of them were randomised to follow something close to the direct program in terms of total diet replacement for 3 months, a food reintroduction program, and then supported weight loss maintenance for the remainder of that 12 months. The control group had dietitian supported usual care, and I must kind of emphasize here that it was they were very well supported by our dietitian. Same dietitian was delivering both groups, but she's very good at her job. And so the people on the usual care group were getting more than what they would have normally been getting if they weren't participating in the study. This is what our participants looked like. So slightly more females in the study than males. We find that's reasonably common with weight loss studies. In the mid to late 40s, BMI of about 40, and you can see that we do have quite a nice chunk of Māori and Pacific participants in our study. We also, in the study, recruited both type 2 people with type 2 diabetes and people with pre-diabetes, which is a little bit different from the original direct study there, which is also why not everybody is on diabetes medication. So what did we find? So weight loss in our direct group here. So you can see this is the control group in red, and our blue line are the people that got our total diet replacement for 12 weeks, the food reintroduction, and then the weight maintenance there. So 6.9 kg weight loss compared to the control group at 3 months. At 12 months, it had decreased slightly, but that actually the decline is actually more to do with the fact that our control group lost some weight there. So seems like it worked in terms of weight loss. We're actually still working on the quantitative results. The publication manuscript should be submitted probably in the next week or two. So that those results are not peer reviewed, but we do have the qualitative findings, which was kind of much more the focus of this study, which were published, which I think is why Catherine asked me to do this, because I think they came out the week that she was talking to me. So Kate, our wonderful PhD student, talked to all the participants about their experiences of the direct study, and then did some qualitative analysis there. So before the study, our participants really saw themselves as quite unhealthy. They'd had negative experiences with health professionals. They'd had negative experiences in terms of particularly the advice they got around weight loss. They felt desperate and powerless, but they did want varying degrees of support. And most of the participants saw the study as an opportunity for change. When they started the total diet replacement, so focusing on our intervention participants, it was physically and mentally challenging, right? So we were asking them to eat nothing but things that came out of packets, so mostly soups and shakes, although there are some little meals now through the program. But it comes out of a packet, you pour it into a bowl, you pour your hot water in, you put it in the microwave, and you consume it. So participants talked about it being really a mind game, but it did get easier over time, particularly because they started being motivated by the weight loss that they were seeing. There were definitely, I think, our participants needed to be more adaptable, possibly than the participants in the UK. So there were definitely times where they felt that they couldn't, for cultural reasons or social reasons, have the meal replacement. So there was some, going and eating real food and then coming back into the program, which required both flexibility and resilience from the participants. And they did report that it was harder to get back onto the program if they'd had a day where they ate differently. But they did see benefit of the total diet program. It was simple to follow, so it kind of took that choice away. So a lot of them, talked about following diets previously where they had to weigh things or measure things or really think about what they were eating. Here, they just had to pick the flavour of what they were eating, so it took away that kind of that worrying that they were making the right choice. And the weight loss did happen quickly, which was a motivating factor for them to continue. The food reintroduction was by far for most people the most challenging part of the study. So they went from following this very prescriptive diet where they knew what they were doing to having to relearn eating patterns or establish new eating patterns that would help them maintain their weight loss. And a lot of people found that they were worried that they were going to do that wrong, or not that it could be wrong, but that they were going to fall off the wagon and they were going to put all the weight back on. All of our participants raved about our dietitian. right? So really strongly coming through that the support was the key to to success, and we've had lots of conversations about um, whether we would have had whether it was something about our individual dietitian or not. And I think possibly she was very had a great rapport with these participants. And possibly not every individual would have had the same level of rapport with that group. So but clearly appreciated the response and the support, and really felt like it made a difference to their outcomes, both actually in the intervention group and the control group there. Um, so in terms of social and cultural influences, that was definitely playing a role in success there. A lot of people are quite, I mean, I completely understand this because putting someone on total diet replacement does feel a little bit kind of icky, but it does work. And the participants did experience that kind of judgment from other people in terms of what are you doing? This is very restrictive. Should you be doing that? Kind of attitude, which they found challenging. And there was some reports around kind of that cultural impact in terms of the fact that the big family gatherings and lots of food there did make things challenging at times. But overall, we found that the program could induce weight loss in this group of participants. They did find it challenging, and we acknowledge that there is definitely a large amount of support that is needed to generate success here, but it was rewarding, and overall, the participants did find it acceptable. So a big thank you in terms of Te Kaika, direct. So Kate Campbell, a wonderful PhD student, has really been driving this research, and Andrew Reynolds is the PI on that project. Big thank you to the staff at Te Kaika and those some funders there in terms of that research. And in terms of the sedentary behaviour stuff, so Jennifer Gale I've already mentioned, PhD student there. Dorothy was a master's student, one of my more recent master's students. Jill is our biostatistician, and then Rachel. The two Rachels, Elaine and Michelle, have also been a great support and funded, like Jill said at the beginning, by the HRC, the Heart Foundation, and Lotteries Health. So there we go. Does anybody have any questions?
Great. Thank you. Thank you very much. That was a wonderful presentation. I'm not seeing anything in the chat. I don't know if anybody has questions. I can't see everybody's hands because of the shared screen. So if anybody wants to speak up, any questions from anybody? So the question I have in that last study that you did, were any of those subjects type 2 diabetics, or were they all relatively healthy individuals? I mean, overweight, but healthy. Yeah.
Oh, and the study in the evening.
Yeah. No, the direct study that you just.
Oh, the direct.
Yeah.
So they were mostly people with type 2 diabetes.
They were. They were.
Yes. Yeah. We hang on, I will go back.
Elizabeth, do you have a question?
Yeah, thank you. That was a great talk. My question is about the use of meal replacements. I mean, there are lots of restricted food intake means that aren't liquid formula that you add water to. How come you chose that? It certainly does focus the subject's attention on the fact that they are going to eat only this food because it's so different. Tell me about that choice.
So we chose to use the Cambridge, I can't remember what it's called now, Cambridge meal replacement program. So it was just kind of an ease of getting products. So they do have a variety of different products, and they're all, every package of food is the appropriate calorie content. So we were trying to replicate what they've done in direct in that manner there. So there is some, like there are shakes, there is little bits of pasta and stuff. So there is, but it's just, I think the idea is just that really it is, I mean, it does, I acknowledge it takes them away from thinking about food, but part of that is an advantage from the participants' perspective in terms of not having to think except to choose which flavor. Yeah.
We package foods and it's restricted energy, so there's not much food there. But we do package foods for people. And I have this theory, which is unproven, that actually looking at a little tray of food and feeling like this isn't a lot, but we make it really high protein and high fat, and that actually eating it is instructional. They feel the satiety because they are seeing the serving sizes and the types of food we're trying to teach them. And so, you know, we're trying to get them to internally realize that they can feel full on a lower amount of food. And I don't know if you would buy that in this group that is in a culture where people are saying you're not eating, you know, what are you doing?
Yeah, we did have participants actually that talked about the fact that they used a smaller plate.
Yep.
Particularly at that food reintroduction phase, or in that kind of cultural gathering. Quite often you'll turn up at those gatherings, and if you don't have a plate of food, somebody will go and fill you up a plate of food, right?
Yep.
So that we did, and our dietitian was very good at talking them through kind of strategies where you pick up a small plate, put something on it when you first get there, so that people aren't commenting. But yes, appreciate your comment about the satiety and getting them used to eating those smaller portions of food. I think ideally it would be probably better to do what you're doing in terms of packaging up smaller portions of food, because that also would decrease the anxiety that happened when they went into that food transition phase where they then had to start making those choices. Whereas if they'd seen what the food looked like on a plate, they could then replicate that themselves probably more easily.
Yeah. And I just want to acknowledge that you had pretty linear weight loss. It didn't, in 12 weeks, it didn't look like it was leveling off, which, you know, good on you. That's amazing.
Well, I think that is the meal replacement, like that is the benefit of the meal replacement, right? If they know that's what they're eating, there's no, and they were like that what, you know, once they started to lose weight, they realized. I think that was also the thing about
it was straight down. That's amazing.
Yeah.
But it's a big reduction in energy.
Yeah.
They do, you know. We actually took people off their blood pressure medication at the beginning of the study because they'd had so many reports in the UK when they were doing the pilot work of people kind of falling over because dramatic reduction in weight also led to dramatic reductions in blood pressure.
Quick question. So how did you measure compliance in the direct study to the meal replacement?
How do we measure compliance?
Yeah.
We did ask them. So they were coming in to see Natalie, our dietitian, every week during that phase. And so they were asked to report how many meal replacement beverages we do. And actually, I can show you the compliance slide if I can find that presentation. It's on a different... adherence. Share this one. So that this is our self-reported adherence in terms of the number of meal replacements. So they were allowed to have up to 4. So you can see most people were started off with having 4. There was some food going on there in terms of the number of real food meals. So some people were having 1 or 2. You can see throughout the day, but really in that total diet replacement, that you know, it's basically the same as the weight loss there in terms of the compliance there. And you can see that there were people that continued to have some. I've got this around the right number of. They did continue to have a 1 or 2 meal replacements throughout the weight loss maintenance phase. Some of that was actually because in this group of people, some people don't have a huge amount of food security, so they were using those meal replacement beverages because they that were provided to them for free. But yeah.
Thank you.
That's all right.
Any other questions? Going back to the research when you were looking at breaking up the day with physical activity during the day, have you ever measured the energy expended in that? Like, I'm just curious, when you do all those small little bouts, how many calories are being expended, and how does that compare to the one bout type thing? Have you looked at that?
We have looked at that, and I can't remember, it was quite a wee while ago, so I can't tell you the exact numbers, but I can send you the publication. But interestingly, what happened was that in the activity breaks, the kind of epoch after the activity breaks was really long. Like much longer than we anticipated. I had a student working on it who was like, I think our machine is broken.
Yeah.
He was like, so we went through the whole thing. We went and got another machine, and and I was like, it is. We do all the right things in terms of calibrating it every morning. How can it be broken? But okay, we got another one. So yeah, really quite long after they sit down that the increase in oxygen consumption is maintained for quite a long time after that. So it does add up to more than when you do it continuously.
Yeah, no, that makes sense.
Yeah.
So there's a question in the chat from Talia. Have you or the studies from the UK followed up with the participants after the study to see if they've been able to maintain weight loss?
Yes. So if you look at the original direct study by Mike Lean and Roy Taylor, they have 2-year follow-up, and they just last year published 5-year follow-up from the study. So there have been some people that have maintained the weight loss and have maintained remission from type 2 diabetes over that time. But the numbers, do get smaller over time. And the 5-year follow-up, just a warning to be careful if you read that paper, because everybody got told the results right at the end of, so the control group was no longer a control group.
Right.
Basically, because at that point everybody was now being told weight loss is amazing, you could go into remission. So everybody was starting to
Yeah. Good.
Yeah.
Any last questions from anyone? No? Well, let's unmute and thank Dr. Peddie again for an excellent presentation. We really appreciate this and taking time out of the beginning of your day to be part of our seminar series.
Thank you so much for having me.
Thank you very much.
Happy spring.
Thank you.
Yeah.
Thank you.
So thank you very much. We had a good crowd here today. Thanks, everybody.
That was great.
Thank
Thank you.
Yeah.